Hello children, welcome to aimsindia's online classes. In today's video, from physics subject, measurement topic we are going to continue. So in our previous videos, we have learned all types of concepts children regarding this measurements lesson. So let's revise the concepts, definitions and formulae, CDF points, and let's discuss some IIT foundation problems children. So let's go through this CDF points once. So any physical quantity which can be measured is called a physical quantity. Any quantity which can be measured, it's called a physical quantity. So there are three types of physical quantities. One is fundamental, second one is derived, third one is supplementary. The physical quantity which does not depend upon other quantities is known as fundamental quantity. Means it exists by its own. It is an independent quantity. It won't depend on other physical quantities like length, mass, time, temperature. These are all fundamental quantities which exist independently. The physical quantity that is derived from the fundamental quantities is known as derived quantity. Suppose area is there. The formula of area is length into breadth. Length into one more length. Breadth is another length. So area is depending upon fundamental quantity length. Density formula, mass by volume. Again volume formula, mass by LBH. So density depends on mass, length. So like this, some other quantities like area, density, force, these are all depends on fundamental quantities. So they are called derived quantities. They are called derived quantities. So to measure a physical quantity, we need a standard of the same quantity. So for measuring length, we have to take the help of unit called meter. For measuring mass, we have to take the help of kilogram. For measuring time, we have to take the help of second. This meter, kg, second, these are the standards of the same quantity. So they are called units. So physical quantities can be measured with the help of standard units. Standard units which are fixed and which are accepted all over the world. So every measurement will be having two parts. Number or numerical value, that is one part. Unit is the second part. N is one part, U is the second part. Suppose 1 meter, in 1 meter, 1 is the numerical part, M is the unit part. Same 1 meter equals to 100 centimeter. Here 1 meter equals to 100 centimeter. Both the values are same. But numerical part is different, unit part is different. This is N1 U1, this is N2 U2. N2 U2, N1 U1, N2 U2. Numerical parts are different, unit parts are different, but still both the values are same. Both the values are same. So the product of N1 U1 is always equal to product of N2 U2. So though they look different, but their product will always be same because this Nu value always constant. Way of representation may be different, but the value will always be constant. If you observe here, the numerical part is increasing, but unit part is decreasing because centimeter less than meter. So the numerical part and the unit part are inversely proportional to each other. If there is more numerical part, unit will be less. Or if there is less numerical part, unit value will be more. So the units used to measure fundamental quantities are called fundamental units. The units of derived quantities are called derived units. So we have some systems children. So principal systems of units. For measuring the units, we have mainly 4 systems. One is CGS system, centimeter, gram, second system, are also called as metric system. FPS system, foot, pound, second system, are also called as British system. MK system, meter, kilogram, second system. SI system means international system. Now the latest modified version of MK system. At present, we are following this SI system. And we have some values children, angstrom. Angstrom. So A naught represented by A. In the place of power, we will keep 0, which is read as A naught, is equal to 10 power minus 10 meter or 10 power minus 8 centimeter. It is used to measure wavelength. Suppose like this, we have wave. This wavelength can be measured by the unit called angstrom. So nanometer means 10 power minus 9 meter. Nano means 10 power minus 9, which is equal to 10 angstrom units. So Fermi value 10 power minus 15 meter. It is used to measure size of nucleus. So micron means mm or mu. Micrometer or micron, mu m, 10 power minus 6 meter. It is used to measure the size of bacteria. Light year means distance traveled by light in 1 year. It is the unit of distance, not time children. Unit of distance. It is mainly used in calculating distance of stars, which is equal to 9.46 into 10 power 15 meter. 1 parsec, parallelistic second. 1 parsec means greater than light year. It is equal to 3.26 light year. It is equal to 3.26 light year used to measure astronomical distances, means very long distances. Parsec, 3.08 into 10 power 16 meter. Astronomical unit, 1.496 into 10 power 11 meter. It is also used to measure astronomical distances. 1 mile, 1.61 kilometer. So all these values you have to remember children. So here light year means distance traveled by light in 1 year in vacuum or air. This is used in astronomy. So actually astronomical unit means the mean distance of Earth and Sun is called astronomical unit. This astronomical unit also used in astronomy. Next, what are dimensions children? Dimensions of a physical quantity are powers to which base quantities or fundamental quantities are to be raised to obtain unit of a physical quantity. So they are dimensions. So dimensional formula means an expression showing the powers to which fundamental units are to be raised to obtain 1 unit of the derived quantity. That complete expression is called dimensional formula. Suppose force. Dimensional formula of force is m0 L1 T minus 2. This total expression enclosed in square brackets is called dimensional formula. Dimension means the dimensions of mass are 0, the dimensions of length is 1, the dimensions of time is minus 2. They are different. Dimensions are only the powers. Dimensional formula means the whole expression which is equal to force. Next, when dimensional formula of a physical quantity is expressed in the form of equation like this: work equal to m1 L2 T minus 2, like this complete expression. So this is called dimensional equation. Dimensional equation. So in general, dimensional formula can be written as mx Ly Tz, where mass has x dimensions, length has y dimensions, time has z dimensions. Or the dimensions of quantity are x in mass, y in length, z in time. So in the dimensional formula, the symbols like M, L, T, they indicate nature of fundamental units, but not their magnitudes. Because we are with the help of this M1, L2, T minus 2, we can just tell only the nature of mass. One time it has appeared. Nature of length, 2 times it has appeared. But is it 10 kg or 20 kg? That we are not going to represent with the help of dimensions. So they represent only the nature but not the value. So dimensions of a physical quantity can be positive, can be negative, can be 0. So how to obtain dimensional formula? From definition, or from the unit, or from the general formula. We can obtain dimensional formula in any way. The physical quantities of same dimensions can be added, can be subtracted, can be equated. If they have different quantities, we cannot add them, we cannot subtract them, we cannot equate them. This is called principle of homogeneity. This is called principle of homogeneity. So if a physical quantity Q depends on Q1, Q2, Q3, then Q is proportional to Q1 A times, Q2 B times, Q3 C times. Because the physical quantity Q is depending upon these quantities Q1, Q2, Q3. So it will be proportional to this dimensional formula. Or Q equal to, if we equate them along with the dependent dimensional quantities, we will get one constant extra, which is K, which is dimensionless constant. Dimensionless constant. Some more values we have to remember, children, while calculating problems. 1 kilometer per hour, 5 by 18 meter per second. The relation between the units of speed. 1 joule, 10 power 7 ergs. It is the unit of energy. Unit of energy. 1 joule, 10 power 7 ergs. 1 electron volt, EV. EV stands for electron volt. 1.6 into 10 power minus 19 joules. It is also one kind of relation between the units of energy. 1 liter, 1000 centimeter cube, or 10 power minus 3 meter cube. 1 HP, horsepower, means motor engines. Their power is measured with the help of HP, horsepower. 746 watts. These are the units of power. Power means work by time. How much work we are doing in how much time. 1 kg weight, 9.8 newtons. Units of force. Units of force. 1 newton, 10 power 5 dynes. 1 calorie, 4.18 joules. Energy units. 1 gram centimeter cube, 1000 kg per meter cube. Units of density. 1 kilowatt hour, 36 into 10 power 5 joules, units of energy. 1 calorie per gram, 4180 joule per kg. So all these values you have to remember, children, so that you can solve any problem. While solving problems, these values will be useful to you. So this all values you have to remember. After that, these values you have to remember. Next, children, let's solve some problems. So level 1. So conceptual understanding questions. So all are single correct. Each question will be having 4 options. Only one option will be correct. Correct answer will be getting, you will be getting 3 marks. Conceptual understanding type questions. So which of the following is not a unit of British system of units? British system means FPS system. FPS system is called as British system. Foot, pound, second. So meter is not the part of British system of units. So option C is correct. Second question. Which of the following unit is not the base unit in SI system? SI system consists of 7 quantities. Meter is a part of SI system. Candela, luminous intensity measured in candela, it's a part of SI system. Ampere, current, part of SI system. Pascal, which is the unit of pressure, it is not a part of SI system. So answer, Pascal is not a base unit in SI system. D option is correct. Which of the third question, which of the following system of units is not based on only units of mass, length, time? SI system, along with mass, length, time, it is having 4 more derived quantities, 4 more fundamental quantities. Already along with 3 existing, it is having 4 more fundamental quantities and 2 more supplementary quantities. So it only depends on only mass, length, time. So SA option is correct. CGS only depends on MLT, MKS MLT, FPS MLT. So option A is correct. Next, fourth question. Which of the following is not the name of a physical quantity? Is not the name of a physical quantity. So time is a physical quantity, speed is a physical quantity, force is a, time is a unit, time is a physical quantity whose unit is second, speed is a physical quantity whose unit is meter per second, force is a physical quantity whose unit is Newton. But whereas kilogram is the unit, not physical quantity. So answer, not the name of physical quantity means kilogram is the answer. Option D is correct. Next one, fifth question. The SI system of units is adopted in which year? So answer, 1961. From 1961 onwards, the units and quantities mentioned in SI system were officially followed by all the physicists in the world. In general uses also, the units are approved officially all over the countries, all over the world in 1961. So the dimensions of a physical quantity are the mean of the exponents of base quantities, wrong. Sum of exponents, wrong. The powers to which base quantities are raised to represent the quantity, right. They are only the powers. Fourth option, sum of all numbers, wrong. C option is correct. So according to principle of homogeneity of dimensions, We can subtract similar physical quantities. Correct. We can add or subtract any physical quantities. Wrong. We can add or subtract similar physical quantities. Right. In first option, they have given only subtract. Wrong. We can add or we can subtract. In the fourth option, we can add a given. Wrong. We can add or we can subtract, or sometimes we can equate. Sometimes equate also can be there. So answer C option is correct. So the eighth question, the dimensions of a physical quantity are powers of fundamental quantities or base quantities. Next, the physical quantity which have the same dimensional formula. So work, energy, torque, three of them will be having same formula. Work, energy, torque, three of them will be having same dimensional formula. So answer option D is correct. Option D is correct. Next one. So which of the following is an example of dimensional equation? Dimensional equation means it should contain equality sign because it is an equation. First one wrong, second one wrong, third one volume equals to m0 L1, sorry, velocity equal to m0 L1 t minus 1. Left side we have the main quantity, right side we are having its dimensional formula, in between we have equality sign. So it is example for dimensional equation. So option C is correct. Option C is correct. Okay, children. So remaining questions. We can learn in our next video, children. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. So you can visit our website, children, www.aimstoday.in, for information regarding online classes, quizzes, live worksheets, do-it-yourself activities, English classes, coding classes, art and craft skills, and other information. Thank you, children. Have a good day.